This is an Arduino Uno connected with a TDS sensor and an OLED display. On the screen, you can see the real-time TDS value of water. Here I have two glasses of water. One glass contains normal drinking water and other one contains the salted water. First, I place the TDS sensor into the normal water. You can see the TDS value on the LED display. Now when I place the same sensor into the salted water, notice how the TDS value increases immediately on the LED screen. This clearly shows how the TDS sensor detects dissolved solids in water. Let's see how this works. We will require the following components for this project: Arduino Uno, TDS sensor, OLED display, per wires. Breadboard. This is a TDS sensor. TDS stands for total dissolved solids, and it measures the amount of dissolved salts, minerals, and ions present in water. The sensor works by measuring the electrical conductivity of water. Higher conductivity results in a higher TDS value, while lower conductivity results in a lower TDS value. This TDS sensor module has three pins: analog, VCC, and ground. The analog pin provides the output signal, VCC is used for power the sensor, and ground is connected to the common ground. These sensors are commonly used in water quality testing, water purifiers, and monitoring systems. Here we have the TDS sensor probe. This is the part that actually goes into the water to measure its quality. The probe has two metal electrodes that detect the electrical conductivity of water. As the ions in the water conduct electricity, the probe sends a signal to the sensor module. The module then calculates the total dissolved solids or TDS value, which tells us how clean or mineral rich the water is. Now I am connecting the TDS sensor probe to the sensor module using the probe connector. The probe connects securely to the module, allowing it to send the water conductivity data. This connection ensures that the module can read the probe signal accurately and display the correct TDS values. Once connected, the sensor module is ready to measure water quality in real time. Connect the VCC pin of the TDS sensor with 5V on the Arduino. Connect the ground pin of the TDS sensor with ground pin. Connect the analog pin with A0 pin on the Arduino. Connect the VCC pin of the OLED with 5V on the Arduino. Connect the ground pin with the ground pin. Connect the SDA pin with A4 pin and STL pin with A5. Before we can read TDS values, we need to install the required libraries in Arduino IDE. First, open the Arduino IDE. In the Library Manager, search for the Adafruit SSD1306 library. If you are using an OLED display, and click Install. Next, search for Adafruit JFX library and install it as well. Then install the TDS library. Then install the library for the TDS sensor. These libraries help the Arduino communicate with the OLED and display the TDS reading properly. Once installed, your IDE is ready for coding and testing the TDS sensor. Upload the code to the Arduino Uno. Now let's test the TDS sensor. Here you can see TDS sensor connected and ready for measurement. On the OLED screen, the current TDS value is 0 ppm. When I place the probe in the water, you can see the TDS value updating on the OLED display in real time. Now when I add salt to water, notice how the TDS value increase further on the OLED. This confirms that the TDS sensor is accurately detecting dissolved solid in the water. So this is how a TDS sensor work with a real-time water testing. We saw how the sensor responds instantly to changes in water quality and dissolved solids. This setup can be useful for testing, drinking water, water purifiers, and water quality monitoring projects. If you found this video helpful, don't forget to like, share, and subscribe for more electronics and IoT projects. Thanks for watching.